All right, hello everybody, and thanks a lot for coming. So I'm giving a talk today called To the Moon and Back, Lessons Learned from Archiving My Open Source Projects. We have a lot to cover, so let's get to it. I'm going to give a very quick introduction to what this project is about, so to set the context a little bit. And I'm going to explain a little bit of the personal history of how this project got started and all the cool things that we did while it lasted. And then the interesting part of the talk, the one you came to hear more about, and we're going to discuss about how it all ended as well and why did I arrive to the decision of archiving it. And some lessons learned from a burned out open source maintainer and some conclusions. So first of all, a little bit about myself. So, 1 second. There we go, that's me as a little boy. My name is Juan Luis. I am originally an aerospace engineer, which is important for the rest of the presentation. But I've been working all the time as Python developer, data scientist, now product manager at Quantum Black, part of McKinsey for an open source Python framework. And that's not the topic for today, maybe for another day. I've been very involved in the Python community in Spain. I was one of the founding members of the Python Spain nonprofit. I organized the first 7 editions of PyCon Spain from 200 attendees to 900 in 2019. And nowadays I'm organizing these meetups, PyData, but in my city, in Madrid. So if you're ever in Spain, please talk to me. We would love to have you there. And yeah, I've been contributing to the SciPy and PyData ecosystem for a long time. So a little bit about poliastro, this project of mine. So poliastro was a Python library for interactive astrodynamics. I don't expect you to know what astrodynamics is. So it's a branch of mechanics, which is itself a branch of physics, that studies the practical problems regarding the motion of human-made objects in space. So not the motion of the planets and the stars and so on, that would be astronomy, but the motion of spacecraft, satellites, and so on. So this library is pure Python. It didn't start as pure Python, more on that in a second. And it was released under a permissive license. It had lots of cool stuff, physical units, astronomical timescales, reference frames, many of these things based on AstroPy, which is another library precisely for astronomy. And it had different propagation algorithms. I'm going to cover what propagation is in a second. And I put a lot of effort in the documentation. So how does this look like in practice? Okay, so, sorry. First of all, these are how the imports look like. So the way to get started with poliastro in 5 lines is like this. So I import the Earth from the bodies and the orbit objects. The other ones are imports from AstroPy. And then I define the orbit like this. So the orbit is made of what is the main attractor, in this case the Earth. What is the position vector, which is this R thing here. And you see that I'm doing some funky stuff here with Python, because then this comes from AstroPy, this is kilometers, and then I use this byte shift operator actually to apply this physical unit to this list, and then it becomes a NumPy array with units. So it's a bit of a syntactic sugar. I do the same with the velocity, which as you can see is kilometer per second, and I define that the time is now. So that gives me this beautiful orbit object with lots of funky numbers over there, which looks a little bit like this. So poliastro gives you simplified schematic 2-dimensional plots like this, and it can also give you nice 3-dimensional plots like this. This is based on Plotly actually, so I can like move around and drag a little bit, and this was very fun to produce, of course. And as you can see, this was only like 1 line of code. And then finally, I wanted to overwhelm you with the awesomeness of this plot right here, which is a way to represent the different time windows we have to arrive to Mars. So on the horizontal side, the horizontal axis, we have the launch date. On the vertical axis, we have the arrival date. And so any point in this chart is a trip from the Earth to Mars. And depending on the position, it takes longer or faster. And these little shapes here behave like that because in the center of these ovals here, the energy to launch the spacecraft is at a minimum. And in fact, if you look online what happened the last missions that we launched in March, they were always like at the center of these ovals here because that's when we spend less fuel. There's plenty of information here. This plot is just gorgeous and it's very widely used in Astrodynamics. And there's much more. So there's a gallery of examples there. And of course, if you're curious, the project still works. You have to use Python 3.10 for that, but it still works. I just generated these plots. And there's much more information there. But how this all started? Well, a young me was studying still aerospace engineering. And this all started because I had to deliver a project, some stuff for university. And this started as a very messy collection of MATLAB, Fortran, Python, all tied together. It was known to work on my machine and probably nowhere else. So if I scroll down a little bit, you see there's no directory structure or anything. There's Python files, some Octave, because I didn't have a MATLAB license, I had to use GNU Octave. These PYF files are actually like header files to wrap Fortran from Python. I don't remember anymore. And lots of Fortran 77 here, really modern stuff. The MATLAB code, and then you see the tests. Some of them were MATLAB, some of them were Fortran, some of them were Python. A beautiful mess, but it had a setup.py and it worked. So I was actually happy I could deliver the project. And then it kept evolving over time. So in 2013, I released version 0.1 and I dropped the MATLAB/Octave code. So this became only Python and Fortran. So I was slightly a little bit more sane as a person. Then in 2014, I refactored the API inspired by another Python library for Astrodynamics that existed back then. And then in 2015, I said, well, there's this new thing called Numba. Has any of you used Numba? Only a few of you. So it's a Python library to accelerate Python code. So you, in the happy path, you put one line decorator to your function and suddenly it becomes super fast. It doesn't always work, but when it works, it's really good. And so I said, well, if I can accelerate the Python code to a reasonable amount, I can throw away the Fortran and then I become a happy person again. And this can be installed in Windows because remember, 2015, like it was the very beginning of Conda and everything. And I'm an old person now. So it worked and then it became a pure Python package and more or less it has remained the same over the years. I presented this at a conference called the International Conference on Astrodynamics Tools and Techniques, and that began like a very interesting story. But before that, you might be wondering, or probably not, but these were the kind of questions that I would get at the beginning, like why not use these other projects that exist out there? And well, more or less the situation was that some graphical user interface programs existed for these kind of tasks, but either they were commercial and very expensive or really bad. Even the NASA made ones that were really, really bad. Then there were some frameworks that were well maintained, but they were written in Java. And I wrote here a very polite thing. I wasn't familiar with Java. I didn't want to touch Java with a 10-foot pole. And then there were some other Python libraries out there, like this one I took inspiration from, but they weren't very well maintained. They were still at the collection of scripts stage. And then why not join forces with Y? This was another question that we got a lot. Like every time a person sees like two projects on GitHub that they're similar, somebody goes and opens an issue and says, hey, why don't you join forces with this other person? And the truth is that I didn't want to. I still wanted to build my own thing for very selfish reasons. Like it was fun, one. Two, the process of building the thing helps you understand the thing, right? So, and this is not something that you get when you use someone else's code, and it was very valuable for me. Starting something from scratch is easier. It's much easier than, collaborating with something that's already there. And, well, I had ideas of my own that I wanted to explore. Having said that, we actually tried 3 people, the ones that signed this article that I shared before. We created a GitHub organization that's still up, that's called Open Astrodynamics. And I think we had 1 meeting, and at that meeting we already realized that we didn't agree on anything. And the effort completely died 1 week after starting, And then that was a very hard lesson for young me, which was that collaboration, cooperation, coordination are very hard because they're human problems. On the other hand, doing the things on your own and making them work, it's mostly a technical problem, right? But they're in a very different orders of magnitude of difficulty. Well, fast forward a little bit, the golden era of poliastro was actually very productive. This is me presenting it at the European Space Agency in Darmstadt in Germany. So I was lucky to have 6 times funding, first from something called the Summer of Code in Space, which was something that the European Space Agency had, similar to the Google Summer of Code, which was awesome. And it was so awesome that they killed it the year after I got it, which was a shame. But then I got 5 times Google Summer of Code, which was really good because it's a €3,000 stipend for students, which is a really good value for money, and not for the instructor though, only for the students. But this was really good. We also became a NumFOCUS affiliated project. In fact, we are still a NumFOCUS affiliated project. And we received 2 small development grants. So the money that NumFOCUS collects from PyData conferences goes, among other things, to this kind of stuff, which is really cool. I was hired by NumFOCUS for 6 months to work on AstroPy coordinates and AstroPy units, which made me realize how difficult it is to maintain a big open source library that has like thousands of users and lots of backwards compatibility constraints. I presented this at EuroPython 2016 and many other conferences, and well, I had lots of fun. And most importantly, I met Jorge, who designed these t-shirts, and a younger Spanish student, and he participated in Google Summer of Code 2018, if I'm not mistaken, and then he became a co-maintainer of the library and a friend. So this was probably the best that I got out of everything. And now for the sad part, right? Yeah, we're doing good on time. So then, if this was going so well, how it all ended, right? And I tried to compress the information here a little bit because many things happened actually for this to end. But I can summarize it in more or less 4 reasons. The first of all is that there was no itch to scratch anymore. There's this cliche in open source, right, that many projects start because you're trying to scratch your own itch. For poliastro, it was no different. But then the moment I stopped using it for my studies and everything, then I didn't have that much of an incentive to continue developing, right? Which I did nonetheless, but I was developing it for my users, for someone else. So it became a bit of a chore at some point. And this was not the definitive thing, but definitely it played a role, especially combined with the other reasons. Then, and probably I could give a talk on each of these 4 bullet points, and because they're so interesting, I got stuck in a local optimum for the project. So, I was able to start really fast. I didn't mention it, but I was basically developing this on the Christmas break and the summer break and the Easter holidays and so on. And thanks to my dependencies, right? Because AstroPy coordinates, AstroPy units already had lots of astronomical routines. Numba made it very easy to accelerate Python code with some constraints. And of course, NumPy that gave us all the infrastructure, right, to work with numerical data. But then I started hitting a wall with each one of these dependencies. So it turns out that AstroPy units is really, really slow. which is a shame, because you're doing unit conversion all the time and so on. And one of the things that I wanted out of the project is that you cannot make these stupid unit conversion mistakes like the one that crashed the Mars polar orbit because one contractor was working in miles and the other one was working in kilometers, right? So I wanted Polyastro to avoid this problem, but then AstroPython unit was too slow because it does lots of meta programming and crazy stuff. And with all the love and respect, it was developed by astronomers, right? So I'm also a non-programmer, so I know the kind of mistakes that we make. So I started a prototype called Fast Units to actually kind of re-implement AstroPython units with a very different concept. And I was studying like the algebraic theory behind dimensional analysis and so on, like pretty dense stuff. And I got it to a point that it was like 10 times faster than AstroPy units, but I needed some more time to continue developing this. Then AstroPython coordinates, I mentioned that I was a maintainer for this for 6 months, and they paid me to do this. And it was still really, really hard to maintain, evolve, and fix the bugs and so on. And because it does like a graph traversal of all the different reference frames that exist. And when you convert between two of them, it's like super complex. So again, I tried to create a simpler version of that, but it was one commit, just a proof of concept of how could it look like. Never got to advance that. Then we realized that mostly of the operations in Polyastro were about a single orbit, and a single orbit is defined by 6 parameters. And so we were using NumPy arrays for all of that because it looked like the natural thing to do. And then a guy comes and says, look, but this has a lot of overheads. We can make this much faster by using tuples. And I said, well, that's impressive, but then we have to rewrite the whole library because it's all based on NumPy, right? And it gave me so much anxiety that I told the guy, look, I cannot handle this at this point. And so actually this link is still up, that proof of concept is still there. And then finally, I mentioned that Numba accelerates your code, but for that to work, your code has to look like Fortran, to be honest. Like very low level, no high level structures, no allocating arrays outside of the function. Now you can actually do it, but it comes with a penalty. So it has like many constraints. And at some point I wanted to make code that was like higher level, like what I was expecting from Python, right? I have a function here and I can pass the function as a parameter. That's actually like very hard to maintain the performance boost of Numba like that. And for this, we had no replacement, basically. It was like we wait for the Numba guys, which are super smart, to fix this at some point, or we go back to writing things in Fortran. And this was never a thing that we found how to fix. Those are like the technical problems. And then there's another thing. You probably have heard from open source maintainers elsewhere, like, oh, companies don't want to give back, right? And I thought that I was not at that stage, that I understand that open source is open source. Like if you read the license, it says, you can do with this whatever you want as long as you retain my name and nothing else, basically. That's what the MIT license says. No warranty is expressed or implied and all of that. But yet, something really irrational happened to me. Like there was this guy that worked at a quite important British satellite company that shall not be named. And he writes me on LinkedIn out of the blue and says, this is a translation. Hi, Juan, I just wanted to tell you that Polyastro is just excellent. Congratulations, greetings. And I was so excited. I replied immediately, like 4 minutes after that, and said, oh, thank you so much for your kind words. Would you be willing to put that phrase in English so I can put it in the testimonials section of the documentation? And then silence. Crickets, forever, until August 2023. That was me who told him, you know what, I archived the project. And that was like the next message in our conversation. And, it was so weird because it was like a message from one person, and his silence, he made me feel so bad, because I just asked for a testimonial. I didn't ask for money. I didn't ask for a job. I just asked for some attribution, something I could put on the website to make me feel proud. And that was basically it. And he went quiet, and this pissed me off to no end. And, think about this when you're using an open source project and you're maybe like opening an issue, complaining or whatever, that open source runs on this attribution, right? Like many folks don't get paid and don't want to get paid, or they don't have the business skills to set up a business model to get paid. But if you say, oh, thank you for your thing, maybe that keeps them going for another year, Instead, after this irrational anger that I got, if I go back to rational mode again, what maintainers should do, like me or other people, is to figure out a business model, right? And the truth is that open source is not a business model. This could be material for another talk, but this talk already exists. So go and watch this one by Adam Jacob, one of the creators of Chef. It's called Reimagining Open Source Licensing and Commercialization and Fair Source. It's really good. It's half an hour of pure gold. But yeah, long story short, if you give away your stuff for free, then don't expect people to pay you in any meaningful way. That's the summary of the thing. But don't take just the summary. It's really good. And then we go to the fourth aspect. I really like music, as I mentioned, and it's funny how every film that's about musicians, it has two themes: drugs or how shitty the music industry is, right? If you think of the biopic of your favorite singer, it's one of these two topics, sometimes both at the same time. This is a scene from Bohemian Rhapsody, the biopic of Freddie Mercury and Queen, and it's like the guy from the record company that says, oh, this song is too long. This will never take off, whatever. But we all love music, right? But nobody loves the music industry. And the same happens with the space industry. So everybody loves the space. It's fascinating, explore the universe, became an interplanetary species and whatnot. But then who pays for the space industry? The Department of Defense of the United States of America. And all the other business models apparently don't work. There's no way to say it's satellite imagery to NGOs that want to monitor the environment or migrations or wars. It's always the US Army paying for these things. And yeah, at some point I got pissed of that. And if that was not bad enough, now it's very trendy to criticize Elon Musk, right? But I'm talking about 2021. This guy was at the apex of his career and public image. It would take us to Mars and, revolutionize transport and so on. But I had crazy conversations with colleagues at work where they said, look, you know what? We don't need to save the Earth. We're going to go to Mars anyways. And I was shocked. I was like, why everybody loves this guy? And I somehow feel that there's something that's not quite right. And so yeah, I ran away from the space industry in part because of this guy. And then he bought Twitter the year after. And I got so massively pissed, you cannot imagine. Anyway, and now 2025, I don't need to tell you what happened. So long story short, because of these reasons and maybe a few more, I finally stepped down as a maintainer. Nice timing though, because I presented poliastro at SciPy US, the conference on scientific Python, in July this year. And then, during volunteer responsibility Amnesty Day, the solstice of December, I stepped down with a very heavy heart, but it was the right thing to do at that point. And then my colleague Jorge, who I also mentioned, gave a talk called in SciPy US next year, what happens when the main maintainer of a project leaves, which was very kind of him, and I will always thank him for this gesture. And then he had to step down as well because of conflicts of interest. And so, long story short, what did I learn, or what lessons can I give out of this experience? So, first of all, I think, and I still think, that open source is the most awesome way of developing software. I've never learned so much as the time that I've been contributing to other people's projects and also maintaining my own. Still, it's important to understand why we're doing it, right? And if we're doing it for fun, we have to ensure that it stays fun. And if it's not fun, it's okay to let a project go. So if anybody here maintains a project that is kind of a burden and they're not making happy anymore and so on, let it go. I forgive you. You can do it. It's okay. It will always be online for whoever else to pick it up and do something else, right? Then it's important to repeat it. Giving back, or companies giving back, is not and can never be a condition for open source. Like, open source is open source. The text of the license is very clear. And so if you don't like this, like creating something for free and then something making millions out of it without paying you, then either you figure out a business model to try to capture that part of that value, or you do something else, or you burn out. Like, there's really no alternative to this. Open source has been always about producing more value than what you can capture, right? So if you don't like this thing, you have to do something else, and it's also fine. There's many different licensing models that are not necessarily open source, and they're fine. And then finally, great projects eventually, maybe not at the beginning, but eventually, they require quality time. And money buys quality time or personal sacrifice. You know, like not seeing your spouse or your kids or your friends or whatever, which is really rough. And you can do it for a while. I contend that you can do it for a period of time, but it's not sustainable in the long run. So if you want to continue developing your projects, and you're incurring some personal sacrifice at the moment, you better figure out how to start getting paid for it, or anticipate what the end is going to be. Anyway, to end with a happy note, was it all worth it? And the answer is a wholehearted yes. I learned a lot. I made new friends. I traveled around the world to talk about this thing that I made. It was making people happy everywhere, like university students in Pakistan, in the United States, in Colombia, many places. And I was very privileged to even be able to do this thing, right? Because I'm healthy, I have time, I don't have like a ill relative that I have to care for. I'm literally at the cusp of the privilege pyramid, and I'm so thankful for that. And open source is above all a labor of love. In case you didn't get the reference, the title of the talk, To the Moon and Back, is from this little kid's tale that is about a mom here that says to its little kid, "I love you up to the moon and back." And I thought it was a very good way to conclude. So thanks a lot, everybody. You can ask me about any of these things. I'll stay around for the beers and happy to connect with you on LinkedIn. Thank you.
Thanks a lot, really. It's a great journey to learn about. Let's see our Slido. Yeah, we do have questions. For the first one, is the t-shirt theoretically accurate?
Is the t-shirt what, sorry?
Is it theoretically accurate? So I guess, have you simulated your bit in poliastro?
Actually, I'm glad that you asked, whoever you are, because it's based on the Voyager mission, the one that was visiting Jupiter and Saturn and so on. So you can see, like, Jupiter and Saturn, this is the Earth and so on. It's not at scale, okay, if that's what you're asking. But it's based on an actual mission and trajectory. So the answer is sort of yes.
I don't know how to read this one. Sorry. Okay, the second one. If Python, NumPy, number, etc. are slow, should we, sorry, microphone. Should we start coding in Fortran again?
Really good question as well. One, Fortran has modernized a lot lately. You know, it gained a community. There was somebody, if you've used SymPy, which is a symbolic calculation library for Python, it was created by a guy that really liked Fortran, so he stopped using Python and he became like a chair. Ondrej Certic, is he Czech or?
Yeah, it's actually, I know him.
Oh wow.
We sketch together, not developed the software, but we sketch together.
Amazing. So this guy became like a chair of the Fortran IEC committee, whatever, and he said, look, we need a package manager, and we need a community standards process, and we need this and this and this. And he managed to do that, and now Fortran actually is cool. I mean, maybe not as cool as other things, but it has a lot to catch up on, okay? Forgive the silly joke. But maybe. And then second, I gave a talk last week about how to accelerate parts of this code with Rust instead of Numba, and Rust was actually twice as fast as Numba, so maybe.
Good. Fortran and Rust to learn. Another question. Do you think ESA or similar organizations should take over the project?
I mean, not really, because the ESA has its own projects. I don't remember the name now. No, I don't remember it. But yeah, they have like their own Python and C++ library for orbit propagation and things like that. The problem with ESA is that we have these weird open source licenses that are like, yeah, this is open source, but only if you are in one of the member states. So like some European countries and Canada, and I don't remember what else. Otherwise, this license doesn't apply to you. And I'm like, guys, why? Like, this defeats the whole thing of open source. But anyways, they're getting it to the open source way of doing things, so give them some patience.
Thanks. Let's see what ESA comes up with. Another one, actually, two questions in one. Do you regret starting this project? And would you start another open source project?
I do not. I absolutely do not regret starting this project. I insist it was a huge learning experience. It made me who I am, basically, this, and contributing to NumPy, SciPy, and other things. Would I start again? Yes, but I would start with a business model in mind up front. And, you know, we could maybe talk during the beers about business models around open source and so on. And it doesn't always have to be getting paid for services or anything. For example, Pydantic, RAF, UV, Polars, they are all now made by venture capital companies that seemingly they don't have a business model. So they are capitalizing on something else, and I have some theories. So, but that's for the beers.
Okay, this question, I don't understand fully, but you may. What did you have to maintain in poliastro? Did Newton drop the new law you have to implement?
It's a very good question, actually. And I'm glad you asked, because I don't know if I'm going to find this easily, but hold on a second. I don't understand this keyword, sorry. Actually, you know, the point of the question is, you know, the laws of celestial mechanics and so on haven't changed forever, right, since Newton or anything. So what's the deal, right? And the deal is that, you know, because this problem is one of the simplest mathematical problems that exist that don't have an analytical solution, has piqued the curiosity of all the mathematicians in the last 400 years, basically. It's just awesome. And there have been, even in the 20th and the 21st century, some new algorithms to solve this thing. 1 second. And during the pandemic, oh, come on. Yeah. I will try 1 more second. And then, and this one. April 25, 2020. You know what we were doing back then, right? We were locked at home. And there was this paper from some Italian guys that created an algorithm so that the propagation of an orbit is continuous, no matter if it's elliptical, parabolical, hyperbolical, or very close to parabolic, which is actually very tricky from a numerical perspective. And I spent the entirety of the lockdown implementing this algorithm, which is really tricky to implement, and I finally got it right. And this was like my last big contribution to science, actually. So yes, there's some stuff to do still in the 21st century about astrodynamics, so yeah.
Okay. This is cool, seeing the science again. What would you do different if you started this again today?
Yeah, like what I said, like I would, anytime somebody comes and says, hey, can you do this feature or whatever, I would go and search their email, and if it ends at, at whatever, maxar.com or something like that, I would go and say, hello, do you by any chance have any budget to get this feature done and things like that? Or maybe I have like a poliastro cloud something, I don't know, like there's several things I could do. But yeah, I would have, commercial users up front from the start so that, we can do something that makes everybody happy. But not Elon Musk.
Not Elon Musk.
He's doing other things now. He's busy.
Okay. What about GitHub sponsorship? Is it not so great for small projects?
Good question. I considered this at the very beginning. I think there were some issues because it was not clear. Like I made a typical mistake of putting some sponsorship levels and then saying, oh, if you sponsor me at this level, then you have like 1 hour free consultancy with me or something. But that is not a sponsorship. That is exchanging money for services and goods, which implies that you have to pay taxes for it and so on. So you're like, it's a professional activity, right? And so when I noticed, I took it down. Maybe it could be a way, but I think this mostly worked for massively used projects. Like for example, for Fast API, for Sebastian, is working really well. For the Pydantic guy, it was working really well as well, Starlet and so on. But yeah, I think this is, when you're catering the broader developer community, this is too niche probably for GitHub sponsors, but I don't know, I could be wrong.
Thank you. Last question actually, a bit similar or related. What do you think about the open source pledge? Companies pledging to donate a fixed amount of money per developer per year to open source projects?
Yeah, it's a really cool project actually. So the guy that is involved behind this open source pledge, I don't know if I'm going to locate it quickly. It's called Chat with Acre. He's been thinking about how to fund open source for more than a decade. And I think they're getting it right now. So the idea here, I guess that's reject cookies. So the idea is that if you're in a big company that's making use of open source, spoiler alert, every company is making use of open source, then you can actually put some money in here and these people distribute it more or less equally, also to projects that are not famous, right? Because what usually happens is that, I don't know, Fast API has what, like 30,000 GitHub stars now, and it's like everywhere. But Fast API depends on URL 3 and Starlet and like lower level things that don't get the spotlight. And so if you just give money to the famous people, then that's not very nice. And so in theory, these folks take care of shuffling it a little bit. And I think it's actually a really cool idea. I wish at some point my dream would be to convince my company to participate in this, but that will come.
Thank you. So this was the last question on Slido. This does not have to be the last question for Juan Luis. Thank you again, really. Appreciate it.
Thank you.